Hello, what's up everybody? This is Papa Bale and welcome to the channel. What I'm looking at here is a new concept for a motor. It's 3-phase. So these line up, okay? And we're going to follow this magnet right here. It's lined up there. And it's lined up here. And that'll happen with every one of these magnets. They're not going to ever hit at the same time, it looks like. Pretty sure that will happen. 1, 2, 3. 1, 2, 3. Yeah. But when we do this, when we line up this one with this one, we get our 120. So one's going to go here, and the other one's going to go here. And we're gonna put 9 coils on there. 3 120-degree circuits. Let's see how it operates with just the one coil per circuit. There's 3 transistors hooked up to this bad boy right now. There are 6 north-faced magnets. So that's running pretty smooth. It's got a little squeak to it. But we're gonna add 2 more magnets per 2 more electromagnets per circuit. So we're gonna have 120 degrees. And it's gonna be bad. It's gonna be so awesome. I bet just one 120 degree would improve it a lot. The coils are 1,000 turns of 26 and 1,000 turns of 30 in each coil that's being utilized. The center one here is a trifilar, and I believe this one is a trifilar as well. So there's a 32 gauge strand in there, but we're not utilizing it right now. $634, $639. Huh. We can do better. $661. Huh. Haha. 665.9. That's funny. $680. $16.8 volts, 1.1 amps going in. 744. 747.7. 749. Alright. We lost the bite there at the end. We were up to like 18 volts. And then it started, the amp started going up and the speed started going down. So 700 at 15.6 and 1 amp. So we're gonna put 6 more coils on here. We're probably gonna do 1 for each at a time and just test it out as we go. See, and I'll slow it down here real quick, just so I can show you how we're gonna do the 120s and why the coils had to be aligned like this. Because the numbers are 1 and 3. Okay, you got 1 coil, 3 positions. And then you got 3 coils. Right now there's only 3 coils. Alright, that didn't make any sense. But it didn't make sense when I heard it. So what I'm trying to say is it's lined up here, right? And then that would make a 120 position here for this coil, and here for this coil. Then we move it to the next coil. Okay? Now the 120 positions are here and here. And then we move it to here. So when each one of these hit, there's going to be an additional 2 that are going to hit for each one of these. And it's going to be awesome. And I think it'll run a lot smoother. I'll be able to put more power into it as soon as I get the other coils into the build. But yeah, man, I think that's great. Actually, I think the current draw is a little high. I don't know why it's so it's at an amp. Maybe it's just because of I don't know, man. I'm using thinner wire. I'm using more of it. You know? And I think it's great. I mean, I have tons of the thinner wire. So we're going to do that. We're going to make either a coil with 1500 turns, or we're going to make it with 2000 turns. And I'm thinking maybe about ditching the maglev, if that's at all possible at this point, and just having it rest on a flange and right on a bearing, because it was shaking like a lot. I think that's holding it up a lot. So yeah, I think I'm gonna either take the maglev off. I'm gonna take the maglev off. I'm gonna have it rest on, say, even this one. Get that glue off of there. Put it on in the position, tighten it down, and then just have it rest on that. I think it would run a lot smoother if this was all on the ground. Anyway, that's what I feel about it. Like if all the coils were on the ground, if the rotor was really, really close. But I think it's too high on the pole. It's too high on the pole. Well, it might just be that the magnets aren't lined up perfectly. But I think this motor is going to be pretty freaking dope. It's going to be sweet. And it even has two 32 gauge strands that are just chilling, not doing anything. And this coil, so. Whew. Yeah. All right. So, gotta get to work. Thank you very much. Peace out. Have a good night. Please subscribe. Bye now.